Let's answer a couple of questions about why we might want to use Minitab or this method rather than just putting in Excel and going and selecting a cubic polynomial for this. So we're going to go back and revisit our case of the polynomial regression in video 3. So the question came, how is the length of a bluegill fish related to its age? And is regression function linear, quadratic, cubic, or otherwise? When we did that, we saw that the p-values for h squared and h cubed were not. Now notice here that the r squared is 80.12%. But if we went to the second or the quadratic, then we've got a 0, 0. So this seems to be the better thing. You notice that the r squared is 80.11%. Just want to remind you that we will always increase the r squared by adding one more predictor. And here we increase it by 0.01%, but still. And if we add too many predictors, we will what's called overfit the data. And so we're putting in too much noise to get the signal, so to speak. So what we could say here at this point is that 80.12 or 11% of the variation in length can be explained by a quadratic function in age. Okay, so this kind of goes back to our phrase that pays, and the r squared helps us out. But again, even though our r squared went up, it didn't go up by very much, and our just sort of test of a coefficient tells us that that's not a good model. The next question is that what is the length of a randomly selected 5-year-old bluegill fish? So if you're going to fishing in Minnesota, and fishing is a big deal in Minnesota. I remember the opening day of fishing season, everybody cleared out of the Twin Cities. The news show spent 50 minutes just on opening day of the fishing season. And they went all around and talked about all these people, how the fish were biting. So anyway, what's the length of a randomly selected 5-year-old bluegill fish? So we go to our model, and let's make sure that we're in the right one. And we're just going to do the same sort of deal before. We're going to predict, I got the wrong one because this is age h squared, so I better go back and redo my regression model and get rid of h cubed. Again, what I want to do is have a 5-year-old. What's the estimate length of a 5-year-old? Let's actually go back to that question. If I randomly select a 5-year-old bluegill fish, should we use the prediction interval or a confidence interval? Now think about that as I go through this. Should I use a prediction interval or a confidence interval if I randomly select a 5-year-old bluegill fish? So as I'm setting this up here, I'm going to go and do my regression and fit the regression model just with 2. And I'm going to do OK with that. And then I'm going to use the prediction part. And I'm going to say age is 5. And I think you could figure out that 5-year-old fish will be 5 squared is 25. If I go ahead and do that, I get a fit of about 165.9. I think that's in milliliters. And so what I could say is, now the question is, do I have a confidence interval or a prediction interval? Well, the answer is I want a prediction interval because I just have one fish. I'm not taking the average 5-year-old fish. I'm saying one fish, so I'm going to have wider variation. And so we would predict with 95%. A 95% prediction interval would say that a randomly selected 5-year-old bluegill fish will be between 143 and 0.487. So this is some of the advantages of using the polynomial regression with Minitab.